This is section 10.7, special segments in circles, starting on page 753. Number 1, find x, assume that segments that appear to be tangent are tangent. So, on number 1, we have two chords. Anytime you have two chords intersecting and how they split each other, we know that the product of these two parts, so 4 times 4, will be equal to the product of these two parts. So 8 times x. We get 16 is equal to 8x, so divide both sides by 8, and x is equal to 2. On number 3, we have a secant line and we have a tangent line. So the theorem states that the tangent squared, so KL squared, is equal to this outer part of the secant times the entire secant length. So the entire secant length would be x plus 4, adding these two parts together. So distributing, we get 4x plus 16. Subtract 16 from both sides, and divide both sides by 4. Number 5, a piece of broken pottery found in an archaeological site is shown. Segment QS lies on a diameter of the circle. What was the circumference of the original pottery? Round to the nearest hundredth. So circumference is equal to 2 pi r, or diameter times pi. So we need to figure out what the diameter is first. It states that QS lies on the diameter of the circle, so QS is part of the diameter. We need to figure out what the other part of the diameter is, so we'll call that part x, since we don't know what it is. Since the diameter is just a chord through the center of the circle, then we can use our chord theorem, which states that the product of these two parts of this chord, so 10 times 10, is equal to the product of these two parts of this chord, so 6 times x. So we get 100 is equal to 6x, so x is equal to 100 divided by 6. From there, our diameter would just be this entire length, so we want to add QS plus S, whatever this is, whatever x is. So we want to take diameter is equal to 100 over 6 plus 6, and then we want to take that diameter and substitute it in to find our circumference. So our circumference would be equal to our diameter, and I'm just leaving this as improper fractions because I'll type everything in my calculator later, times pi. So on the calculator, I'm ready to type in 100, back up, parentheses, 100 divided by 6, plus 6, close parentheses, times pi. And from that to the nearest hundredth, we should get 71.21 centimeters. For number 7, find x to the nearest tenth. Assume that segments that appear to be tangent are tangent. On number 7, we have two intersecting chords, so we're going to use the theorem that states that the product of these two parts of this chord is equal to the product of these two parts of this chord. And if we divide by 6, we get x is equal to 5. Using the same theorem on number 9, so the product of these two parts is equal to the product of these two parts. So if we distribute, we get x squared plus 10x. And if we FOIL, or double distribution, we would get first times first, outside times outside, inside times inside, and last times last. If we simplify this, we can subtract x squared from both sides. We would get 9x plus 14 on the right. So subtract 9x from both sides, and x is equal to 14. On number 11, we have two secant lines. So a secant is a line that intersects the circle in 2 points. So we have two secant lines. The theorem states that the outer part of this secant times the entire length of the secant, remember that we have to take 12 plus 2 there to get the entire length, will be equal to the outer part of this secant, so the part on the outside of the circle, times the entire length of this secant. So for this secant, its entire length would be 6 plus x, or x plus 6. So we get this equation, and we need to distribute. Now notice here we have a quadratic equation, so we want to bring everything over to one side, so subtract 28 from both sides. And my a term, so that's my coefficient here, is 1. My b term, my coefficient here, is 6. And my c term, my constant term, is negative 28. So we're going to substitute those into the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let's see, opposite of b plus or minus the square root of b squared. 6 squared is 36. Minus 4 times a is 1, so we don't need that, times c is negative 28. All over 2 times a. 2 times 1 is 2. And we're just going to simplify this. Okay, so notice that this gives me two answers. I would take negative 6 plus the square root of 148 and divide that by 2, and negative 6 minus the square root of 148 and divide that by 2. Now obviously, if I subtract from a negative, I'm going to get a bigger negative, which means that my answer is negative, which is impossible. We don't want the negative value. That's an extraneous solution because x is a length here. So we just want the positive. So let's take, with our calculator, negative 6, put that in parentheses, plus the square root of 148, close parentheses for the numerator, divided by 2. And we should get approximately 3.1. Number 13, we have a secant intersecting the circle in 2 points and a tangent intersecting the circle in 1 point. So the theorem states that the tangent squared is equal to the outer part of the secant times the length of the entire secant. So x plus 12 would be the entire length. Distribute. Once again, bring everything over to one side, get the quadratic in standard form. And my A is 1, my B is 12, and my C is negative 144. Substitute those into the quadratic formula. So we have the opposite of B plus or minus the square root of B squared. 12 squared is 144, minus 4 times A, which is 1. 4 times 1 is 4, times C, all over 2 times A. 2 times 1 is 2. And simplify. Okay, once again, we only want the positive answer, so on our calculator we just need to take negative 12 plus the square root of 720, all of that divided by 2, which is approximately 7.4. Number 15, Sierra is serving cake at a party. If the dimensions of the remaining cake are shown below, what was the original diameter of the cake? So my diameter, which goes through the center, the rest of it would be right here. So we'll call that part X. Now, if this chord has a length of 12 and my diameter is perpendicular to it, then it will bisect it. So half of 12 would be 6 here and 6 there. So I'm going to use the theorem which states when I have two chords, the product of the parts of this chord will equal the product of the parts of the other chord. And x is equal to 4. Now, go back to the original question. What was the original diameter of the cake? So I'd have this part, which is 9 inches, plus this part, which x is 4. So 9 plus 4, or 13 inches. Number 17, find each variable to the nearest tenth. Assume that segments that appear to be tangent are tangent. Number 17, two secants intersecting outside of the circle. I want to take the outer part of this secant times the entire length of the secant. Now, the entire length would be x plus 2x, or 3x. And then set that equal to the outer part of this secant times the length of this entire secant. So I'd have x plus 4 plus 8, or x plus 12. So outer part times whole thing equals outer part times the whole thing. So this would give me 3x squared, and if I distribute, I would get 8x plus 96, and we have a quadratic again, so get it in standard form. You always want your squared term to be positive, so that means I want to subtract 8x and 96 from both sides. And I get this. So now my A is 3, B is negative 8, C is